Hey, Mr. Shapleski here. We're going to be reviewing for week four's test. These are the problems you have to do. So you might want to pause this video right now and spend, I don't know, like 10 minutes going through these 5 problems, see if you're successful. And then you can come right back to this review at this moment and I will go through all the answers. Okay, here's number 1. So you're supposed to name 2 angles between 0 and 2 pi that are coterminal with negative 7 pi over 3 and 17 pi over 5. Now 7 pi over 3 is where we start. It's a little easier one because it's more traditional when you do over 3 on the unit circle. 17 pi over 5 is a little bit more of a challenge. So let's start with that negative 7 pi over 3. So I did that all here. I kind of counted my thirds. Now you could have absolutely did this in 6 by doubling the top and doubling the bottom and doing 14/6 and counting every 6, but I chose thirds. So 0 thirds, 1 third. I'm sorry, I'm going backwards because it's negative. 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds. 7 thirds is this exact point right down here. And if you kind of really detail the unit circle, there's the 45 guy and then there's the 30 guy, but this is the third one. So that's the same as 5 pi over 3 on your purple sheet. So that's an easier one to start with. As you move to the second one, 17 pi over 5. Now, first of all, how do you do 5? Well, if you know that, I'm going to kind of illustrate that on this one. If you know that this is 1 pi, all this stuff over here on the top half, you have to then split that into 5 little like pie pieces. So that's kind of where I started. I go this way. So if you do 5 over 5, because you want this to be in fifths because of the denominator, 5 over 5 is the same as 1 pi. So that's kind of where you start. So then on the bottom, you have another 5 pi pieces. So then when you go all the way around, 10 fifths is 2. So then I need to count again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15. So 15, oh, I got to go 17, 16, 17. So this is my ending position where 17 pi over 5 is going to be. So now if you want it to be between 0 and 2 pi, 5 goes into 17 over 3 times, 3 and 2 fifths. So if I split that into a mixed fraction, 3 and 2 fifths, and I know that 2 pi is a full circle, I could really take 2 of these 3 away, and that's like 1 and 2 fifths. And 1 and 2 fifths is 7 fifths. And you could count this by the pi pieces also. 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths, 6 fifths, 7 fifths. So this is really 7 pi over 5. Now, there are probably about 3 different ways to do this. This is the way I do it because it's really simple, I think, but you do have to have some fraction knowledge. But there is an optional way, and that other optional way is to kind of convert it into degrees. You work with degrees because it's a little bit easier, and then convert it back. So if you do 17 pi over 5 times 180 over pi, the pi's cancel. 17 times 180 divided by 5 is 612. Just use my calculator. And then I know a full turn is 360. And when I say between 0 and 2 pi, that degree mode means 0 and 360. So I'm going to take a spin out of it the same way I took a 2 pi out of it. So if I take a 360 out of 612, I've got 252. So this orange traversing around the unit circle is 252 degrees. So when you do that 252, I'm going to slide this down a little bit so you can see all this. Now I just need to convert back to radians. So multiply by pi over 180, and then it's 252 over 180. Go to my calculator, do 252 divided by 180, second PRB, second ABC if you have a TI-30, and that'll end up with 7 fifths. So hopefully that's enough. That's a little bit of calculator and fractional work. This next one's much easier. What's the reference angle to 1080 degrees? Reference angle is an angle somewhere from 0 all the way up to 90. So it's that first quadrant angle. And this is kind of a trick question because your answer is 0. So I kind of did this with this purple spin. One spin is 360 degrees. So I take 360 away from 1080, and then I do another one. I'd be doing this all on my calculator. Take another spin away from 720. I'm down to 360. Take another spin away. I'm actually at 0. So this 0 is my reference angle. And remember, reference angle has to be anywhere between this and this. So it's got to be in this quadrant somewhere. It could be on the quadrantal angles, which it is. So example 3, name the 6 trig functions of the ordered pair on this graph. Which graph? Well, this is the graph they gave you. So this little black arc shows you went 150 degrees around. So if you look at your purple sheet, or if you just have this memorized, which would be my preference, here is your ordered pair for that point. So now the sine, cosine, and tangent is relatively easy. Take a look at those. So cosine is the x value, sine is the y value, and tangent is sine over cosine, y over x. And then don't forget to multiply by reciprocal. You end up with this guy. And this guy needs to be rationalized, so then you really end up with that. And then as for secant, secant is the reciprocal of cosine. So here's cosine, flip the top and the bottom. So the 2 goes to the top, the negative square root of 3 goes in the bottom, and then rationalize denominators, you get this. Same thing with cosecant. The reciprocal of 1 over 2 is 2 over 1, and then cotangent is just flipping this guy. Actually, it's probably pretty smart to go back to the non-rationalized form, because if you flip this guy, you have to rationalize your denominator, and if you flip this guy, you don't, because it's this over 1. So there is your practice on cosine, sine, tangent, secant, cosecant, and cotangent. And as for the graphs, so here's the first graph. The first thing is this is going to be a period change. This is going to be an amplitude change. So I start with figuring out the period. So it's always 2 pi divided by b, and my b is my 8, the number in front of this x. So that ends up to be 2/8, which simplifies to 1/4. So I know that my ending is going to be here at 1/4. So I need to cut 1/4 in half to figure out my middle. So 1/4 cut in half is 1/8. So this is 1 pi over 8. And then if I wanted to figure out these other ones, because remember, I'm thinking about 4 pieces of my unit circle. When I graph a cosine, I go high, midline, low, midline, high. Unless there's a negative, all that kind of gets reversed. We'll talk about that in a second. So I need to get these 4 quadrantals. So if I take a half of 1/8, I get 1/16. So every one of these is 1/16 away, 1/16 pi. So now that I broke this up, I just need to kind of do my dots. And my amplitude is negative, so I got to reflect this guy. So instead of starting like up here, 3 higher, midline, down, midline, up, I just push all that in reverse. The midline stays, but when it starts up high, it actually starts low. So a cosine, instead of going downward, when you have a negative, it goes upwards. A little weird like that. So that is your example 4. And example 5. Sketch the graph of a sine function, now it has to be sine, whose period is pi over 3, amplitude is 2, and midline is -3. So I kind of did this in backwards order. So my period is pi over 3, so then I kind of put my 4 marks, or 8 if you want to do these middles, which is fine. And I cut 1/3 in half, and I got 1/6. I cut 1/6 in half, and I basically multiplying the denominator by 2. So I cut something in half, and I get 1/12. So every one of these quadrantals is really like 1/12. The midline is -3, so you go down 3, and you make your dot. And I keep going with that, so that's kind of what I move to over here. And then the amplitude is 2. So if the amplitude is 2, here you go for this problem right here. So I need to go 2 above this line. So if I am going to -3 for my midline here, 2 above -3 is -1, and 2 below is -3, -4, -5. Or I'm sorry, 3 below, -6. And if I really wanted to write an equation of this, I could. The tricky part is coming up with that b. So 2 pi divided by b gives me my period. And my period is pi over 3. So if I wanted to kind of calculate that, y equals amplitude, -3, I'm sorry, 2. Oh, my amplitude is 2. Hold on, I think I made a mistake here. So my amplitude is 2. So let me go back to over here. So I go 2 above this line and 2 below this line. That should be right there. It should be a little teeny bit higher. My bad. I was confusing midline and amplitude. So the amplitude is 2, and it's a sine function. So sine, and then it's something times x, and then I have to do plus the midline, or minus, plus a -3 or -3. But here's the key. If you finding b is not that terrible, you multiply both sides by b, and then you divide by pi over 3. So I'm going to kind of come up over here. So it's 2 pi, and then you divide both sides by pi over 3 to cancel this. Divide by pi over 3. Cancel that, and you do the same thing over here. So it's 2 pi divided by pi over 3, and that equals my b. And I'm going to change colors here so it doesn't bleed into this. And then how do you do dividing of fractions? It's 2 pi multiplied, and I'm going to put it over 1, multiplied by the reciprocal, 3 over pi. So the pi's cancel, and you get your b to be 6. So then that's what goes right there. That's always a trickier one to go backwards like that. And the only thing that's really tricky is 2 pi over b equals the period. And the period goes right there. And then you just have to know how to solve your equation. So that's it. I hope you got a lot out of this. It's a little trickier of a lesson, but good luck with your studies, and I hope you do